So working on the HCH2 inverter, and what we've got now on the circuit board here is, hopefully you can see, is this little gadget here, and this is sitting between the dumb inverter side of the motor control module and then feeding into the motor control module via the optos that I mentioned to you on the previous video. So basically I've disconnected the opto, now feeds into this PIC on the isolated, on the low voltage side. So the output from the opto is feeding into this PIC. So this is pulling its 5 volts from the MCM side, and basically this intercepts the serial data and then spits it back out again towards the MCM. So by manipulating the data in the PIC, we can reduce the voltage that passes through towards the motor control module here. So we should be able to make the HCH2 inverter see what voltage we want by reducing the voltage coming from this side, the sort of sensing side, by a percentage that we decide to reduce the voltage by. So say the voltage of our pack is actually 250 volts. That would be too high for the inverter normally, so what we might want to do is we might want to reduce that by down to 200 volts. So we would just change the code in here so that it reduces the voltage passing through the serial data voltage by a required percentage to reach our target voltage of 200, so knock off 50 volts basically. So that's basically what that does. It's got some various connectors on it at the minute, and these are all logic probes, and I've just been looking at the signals, and I haven't got my variable voltage power supply yet because I want to do some work on actually making up a lookup table maybe for the voltages and the data that passes through. One of the variables is very, very accurate, but then there's another double byte of information which is like 50 volts higher than the other, so it's a bit strange. So, but basically I would just reduce them probably both by the same percentage and see what happens. So that's just a little tiny gadget that fits inside the inverter, and you can see it's got some programming pins and a jumper on the end here. So the idea is when you want to program it with the PIC programmer, you can do it without taking the whole unit out of the car. I'm just going to make a slot in the side of the inverter case so that you can get access to these pins in the jumper. And the idea of the jumper is that when you're programming, you remove the jumper so that the PIC programmer isn't trying to power the whole of the board with its very limited 5 volt onboard supply. So that's basically the gist of that. If we look at the display, I've got a display here. This is displaying the data passing through, 48,000 bit per second. It's actually 8 data bits, an odd parity bit, and not an even parity bit as I thought before. So I was looking at that, took a while to work that out, but the data was a bit weird. So it's actually 8 data bits and an odd parity bit. And then we've got a voltage here which is coming out on the CAN bus. If I connect to my power supply here, this is about 207 volts or something like that. So if I power that up and we go back to here, we should see in a few minutes, if I connect it out properly, that we get the voltage on the display. I've probably done something wrong there. Let's just restart it. Turn it on. Yes, and we can see on here we've got 207.25 at the bottom there, and that's actually the voltage. And it's very accurate as well, the voltage that's being sensed by the system. So that's quite interesting. So that's what we've got at the moment. Got a logger there so I can look at the data coming on the serial bus and on the CAN buses. And then we've got the little tiny gadget here which allows us to intercept that serial voltage data signal and manipulate it. The same sort of principles I used on the HCH1. That has a separate motor controller and a dumb inverter, so you were able to intercept the signal a little bit easier, whereas it was just in the normal cable harness. But now this one we've actually had to go into the inverter to do it, but it's exactly the same principle. We're just intercepting the voltage being sent out by the dumb side of the inverter to the motor control module, and we're going to manipulate it and reduce it down by varying amounts just to see what we can do. And as we know, we can manipulate the data or the voltages into the battery control module for the HCH2 just by using the resistor matrix with a pre-resistor divider to drop the voltage down by a certain percentage. So whatever percentage I use on here, I will program into the PIC on here to reduce the voltage that it sees, and then hopefully the two devices should have correspondingly close voltages enough to function normally. So that's what I'm working on at the moment.